We're going to talk about, as Ali mentioned, DeFi actions. We're going to start with some visuals, but I guess before I do, I'll just reiterate what Ali has already said about DeFi actions, which is DeFi actions is basically trying to make building DeFi workflows like stacking Lego blocks. You might build something with like the same bricks that I use, but we could build entirely different things. And so DeFi actions is a really modular set of interfaces that you could either build your smart contract with, you could build user flows with, you can build autonomous DeFi agents scheduled through scheduled transactions with. So yeah, without further ado, let's dig into the basic connector set.
I love it.
So the basic connectors, as you might imagine in DeFi, regardless of whatever the details are of an underlying protocol, like a swap protocol or a lending protocol, you're in DeFi, you're generally doing one of a couple of things, right? You're either depositing tokens, withdrawing tokens, you are swapping tokens, maybe you're getting the price of some tokens. And so the DeFi actions interfaces are largely around those actions siloed to a single intent. So the sink and the source are going to be your basic connectors where you're going to deposit tokens. You put tokens into a sink, you pull tokens out of a source. Relatively simple. What's actually going on underneath the hood doesn't necessarily matter to you as someone who's building with DeFi actions. If someone hands you a sink, you know you could put tokens into it. Moving on from those, we have a swapper. Again, I'm swapping from token A to token B. I put in token A, I get out token B from the swapper. That could be a protocol on like a cadence-based protocol like Increment. It could be a Uni V2 or V3 pool like Kitty Swap, integrated in Flows EVM. But you know that if you get a swapper, you can put in some tokens that it accepts and get out the tokens that it returns. And then a price oracle, pretty simple, right? I ask a price oracle for the price of a token. As long as that token is supported by that price oracle, I get back a price. You can start to combine these to create some pretty basic workflows. So for example, I have a swap sink here. And a swap sink is a sink. It looks like any other sink. But internally, it's taking the tokens that you put into it, and it's putting them into an inner sink. So you put in token A, it swaps to token B and puts it somewhere else that accepts token B. Similarly, you have a swap source that on the surface can be treated like any other source, but it's pulling token A from somewhere. It's swapping them and then it returns token B. All you see when you're interacting with that is that you can get out token B. We're not going to talk too much about the AutoBalancer, but the AutoBalancer can accept deposits and will provide you withdrawals of that same token type, but it tracks the value of those deposits over time. So if I put in, for example, $100 worth of flow, that $100 will be noted in the AutoBalancer, and it does that with the price oracle. Importantly, as the price of the value of that token fluctuates over time, let's say flow goes up. Now that flow that I deposited at $100 is now worth 150. That AutoBalancer will try to maintain that $100 balance over time. And as long as it's configured to do so, once you tell that AutoBalancer to rebalance, either through scheduled transactions or manually, it'll take that extra $50 balance and then it'll push it somewhere else. So this is really useful in more complex DeFi workflows. But importantly, the AutoBalancer itself can be plugged in as a sink and a source into other workflows. That is, like, in terms of just where that is currently, scheduled transactions are being built into that. So that's kind of in flux. I'll stop there before we move to like actually looking at the code. Any questions so far? All right, cool. So I prepared this repo. You could scan the QR code there. I'll give you another minute or so. But we're going to look at the simplest workflow construction. The simplest one that I could think of is I'm taking tokens from someplace and I'm putting them somewhere else. We're going to see how in a transaction you would compose that, and then how you could basically take that plumbing, store it on chain, and execute that workflow as you wish. Again, we're not going to look at I didn't include scheduled transactions just to reduce the complexity and focus really on DeFi actions. But you could extend this example and add scheduled transaction functionality and then execute these workflows basically like an autonomous on-chain agent to execute your DeFi workflows. So, all right, let's take a look at the code. So I'm going to start here. Hope you guys can see that here. I'm going to focus on the sync first. And as you can see, these interfaces are relatively simple. The sync will accept a certain token type, and it will accept deposit. It does that through the reference. I'll just note here that the intention of DeFi workflows is of DeFi actions is to allow for graceful failure. So this sync might only accept 10 tokens, but you might try to deposit 12, and you don't want that sync to just completely blow up the rest of your workflow. You may just want it to take what it can and then move on with the rest of your workflow. So that's why we take a reference here. But that's the sync. The source is similarly simple. You can withdraw, and the source will accept a certain amount, and it will accept a single token type. So those are the two most basic connectors. We'll move on to the swapper, which I'm not sure how many of you are familiar with like Uniswap, where you can get a quote. You can get a quote for how much of a certain token is required for the amount that you want. You can also get a quote for how much will you give me if I give you 10 of this other token or provided here. And then you can swap in the default direction, which is in to out. You can also swap back if you have like some residual. So those are the connectors that we're going to deal with. And I'll show you here what that actually looks like in implementation. Because again, these are interfaces, and importantly, they're struct interfaces. So great. Any questions about those interfaces so far? Cool. All right. So what I've prepared here is a super simple wrapper for some DeFi connectors, DeFi Actions connectors. And this is a simple workflow. I'm just transmitting tokens from an origin to a destination. So I take tokens from a source and I stick them in a sink. Now, on the surface, it's honestly, it's really not all that interesting, right? That's basically a token transfer. In its simplest form, I'm just transferring from my account to Ali's account. But the variability and the degree of flexibility that you have is basically the world is your oyster. You can put any sort of complex logic within these actual connectors that will allow you to then ping this transmitter to transmit tokens from the source to the sink. Yeah, I'll leave. How much? Um, so right. So the simplest form again is going to be a transfer, but again, I could use this to, I don't know, maybe I set this up to like do like a bill pay, kind of like an on-chain subscription fee. I want to pay my Netflix on-chain. The other thing that this could actually be useful for is, let's assume we have some source that's providing me with my staking rewards, and where the destination is basically my staking delegation. And so through this, I have all of a sudden, I just plug these things together, and now I have restaking. I'm compounding my staking rewards. I go from the origin providing me my staking rewards and tossing it back in. Um, the other thing that we'll take a look at here in a second is maybe I want to have like a buy strategy. I want to take my my USDF and I want to swap it into Flow, and I just want that to be super simple. I just want to call this transmitter to transmit the tokens. And with a swap sync, as we saw earlier, I could take the USDF and I can stick it in here, and that'll swap into Flow and kind of continue on its way. Yeah, there's quite a lot of variety that you can do even just with this. I'm going to show you what that looks like, and that, in my opinion, what the benefit of this of actually putting this plumbing into a resource like this entails is, I can, if I were to extend this with scheduled transactions, I could run it in an automated manner. But moreover, I can run a simple transaction that is basically just transmitting the tokens. I'm just calling transmitter.transmit tokens. And I have a huge amount of variety that is available to my users. If I'm running a service that allows users to set up these DeFi workflows, I could just have them run this transaction against any transmitter they may have configured, and I can now execute a whole huge number of different DeFi workflows. So yeah, that transmit tokens is relatively simple. It's a couple lines of code. I'm getting the amount that I'm going to transmit. I'm going to withdraw from my token origin. I'm going to make sure that I actually have a non-zero balance, and then I'm going to deposit that into the token destination. So relatively few lines of code. And again, Lego blocks coming into play here. If as the library of DeFi Actions connectors grows, you can pull from those connectors and just compose the transactions that set this up, and the actual composition is made much simpler than actually integrating directly with these protocols. So before I start with the simple just transfer workflow, does anyone have any questions about that? Cool. So I'm going to run my emulator, and I have a setup script that I'm going to run here so that we can get the local environment set up with an increment swap pool. And all of this stuff is in that repo that I had linked earlier. Make sure we're all good. Yep, we're all good. And so let's take a look at the simplest version of this. So I'm going to set up a simple transmit, and this is going to set up the account so that I can transmit tokens of the same type. I'm just going to transfer flow from the signer's account to a recipient's account. What does that look like? I need a transmitter, and I need a place to save that thing. I'm going to give in some like vault type. I'm going to get a capability to that vault. I'm just getting a capability to that vault to withdraw, and then I'm going to get the capability on the receiver's account. So I'm getting the recipient account, and I'm getting a capability to their vault. And before we get into actually creating these connectors, you can see it's pretty simple to just instantiate one of these connectors. You can imagine that as you get more complex, it's kind of difficult to trace what's going on through these events. So DeFi Actions allows you to basically tag the events with a unique identifier that's shared across all connectors in the workflow. So we're using that same unique ID in anything that's going to be incorporated in this workflow. So what do? We get a vault sync and a source, which just allows someone to deposit and withdraw from the origin capability, right? That's going to be in the signer's account. And then we have a place to put those tokens, which is going to be the destination sync in that transmitter. We create the transmitter, and then finally we save the transmitter. We just have some pre and post conditions to make sure that the transmitter is successfully saved. So pretty simple. There's quite a lot of comments. This could be actually a relatively small amount of code. And with that, along with the transmitter, we have the ability to routinely transfer tokens. So I'm going to go ahead and create another account. I'm creating another account here. Let's make that a little bit bigger. I'm going to name it emulator recipient. Dangers of, let's go to my accounts. I'm just going to remove this account here that I already have. Great. Exit this and create that account again. Emulator recipient. That's going to be on emulator. Great. So now I have another address that can receive the flow when I transmit tokens. So let's grab this address. And again, let's look at the transaction. We're going to need a transmitter storage path. I'm going to run the transaction to set up the simple transmitter. And you can see my history is already giving me away. I have the storage path. I have the vault, the flow token vault that I want to make sure the transmitter is set up for, the recipient, and then how much I want to transmit every time I call transmit. So let's make this a little bit bigger. You can see the events as they're firing off. I'm going to run this, and great. So that's been configured. Now all I have to do is run that simple transmit token. And again, just to refresh your memory, we just need to know where that transmitter is and expect an amount to actually transmit over. Great. So let's run that transaction. I'm going to run against that simple flow transmitter. I'm going to expect that 10 are transferred. And we should see in a minute here the event that were fired off. Okay. Let's see what went down. I think I entered the, here we go. Wrong storage path. I'm going to expect 10, and I'm going to input the simple flow transmitter. Great. So we could see that the amount was withdrawn in this first signature, in this first event. From the emulator account, we withdrew 10, and then finally we end the transaction with a deposit to that emulator account that we created of 10 tokens. I could run that again, and that'll transfer the same 10 tokens. So again, if this was scheduled, now I have on-chain subscription payments. I could, transfer over to some other account and auto pay my on-chain subscription. Currently, we're just transmitting that every time we fire off that transaction. So simple enough. Let's revisit the token origin and destination. And again, any conformance will fit in here. This transmitter will accept any DeFi Actions sync source composite and a sync. So again, we could use this as we could take that same fungible token source and sync that will withdraw tokens from the signer's account, and we can deposit that into a swap sync. So let's say I want to set up a token buy workflow that will swap me from flow token to some other token A. Let's see what that would look like. So this one's going to be a little bit more complex. In this case, I'm just hard coding the existing token path that I know that I know is already configured. But you could kind of generalize this to swap along any path. If anyone's not familiar with like DeFi and swap pools, generally you have a kind of like a hop path. So if I'm going from flow to token A, my path is basically going to define flow to token A. But in some cases, you might need to make a couple hops. Maybe there's not a swap pool with that. Maybe I need to go from flow token to USDF to token A. But in this case, we set up a pretty simple swap path. So that's where we're going to go down. We're going to take a max transmit amount. So let's say I only want to transmit up to 10 flow at a time. And I only want to do that until I have, 1,000 token A. And then I don't want that to transmit any longer. So you have some degree of like flexibility, even when you're piecing these Lego blocks together. So what do we do here? We initialize the swap path. We get the types of the tokens that we're actually going to be swapping in and out. We get some metadata about them so we know where to find them in the signer's account. And then we get a capability to that. We set up the other token. If let's see, I am noticing I actually had a typo here. Great. So we are getting the withdrawal capability. Then we're setting up the vault for the token A that we're going to be swapping into. And then we start to piece together the connectors. So the first connector is the same one we saw in the first very simple case. It's just a vault sync and source that lets us deposit and withdraw to a vault. And then we're going to create a swapper. This is an increment file swapper. So this is basically what it looks like for your workflow to integrate with a swap protocol. You need a connector. You just instantiate that connector in the pattern that is required to create that connector. In this case, an increment file swap connector. And then we need to create a vault sync because again, we're going to have a swapper and a sync to create a swap sync. So we're kind of working in reverse order a little bit. Sometimes it feels like. So we create the swapper, we create the vault sync that will allow us to receive the swapped token. And then we put those things together right? We're just sticking those Lego blocks together in the swap sync. And then finally, we can create our transmitter. And then we just save that thing into the signer's account. So let's see what this, I just made some live edits. So let's cross our fingers. So this time I'm going to set up an increment swap transmitter. I'm going to save it to swap flow transmitter, and I'm going to transfer 10 up to 10 flow at a time, transmit up to 10 flow at a time. And in terms of my up to amount, we have that third argument here. I only want to do that until I have 1,000. Let's say 10,000 token A. This should work. Great. So that's been, I can see that that transaction went through successfully. And in this case, I'm actually not transferring to anyone. I am just swapping and depositing that into my own vault, the vault of the signer. And that is, we know that because of the receiver capability is coming from the signer's account. That's who's going to receive the swap tokens. So let's go ahead and run that transmit swap flow transmitter. And I'm going to expect that 10 flow are transmitted. Let's cross our fingers, and that worked. Great. So we set up the transmitter successfully, and I can see, if we look at these events, there's quite a few more events than originally, but we're withdrawing flow token. We have the 10 flow here. You can also trace the DeFi Actions events with the unique ID. But in this case, we withdrew 10 flow, and then at some point we swap them. At some point we go from flow to token A, and we can see that in increments events. We have a swap pair swap from flow to token A. We can see that ratio, and we got a little less than 10 token A because they were set up with equal reserves. And then finally, we should see that the token A was deposited into that same account. So we can see how much token A was deposited at the end. So again, that's basically a buy strategy that I can execute manually. But if you were to add a scheduled transactions conformance in here, you would be able to then set that up to run as like a DCA strategy. So that's basically what I have to demo for you. I would definitely encourage you to just kind of look at these transactions and what it looks like to go through. And even in the simplest case where you're only dealing with 2 connectors, to look at the sequence of how you put these connectors together, the accounts that you're actually sourcing these capabilities from. But once you start kind of creating workflows in this way, it feels quite a bit like you're dealing with like Lego blocks that you're just kind of piecing together. Yeah, so I'll paste the link for this repo in the chat here.